audience. Doing a quick live stream here about space weather. So welcome to the Daily Space Weather Show. You may have noticed some intermittent outages in our coverage, and it's because of a number of factors, but we'll have to cover that at a later time because there's plenty to talk about when it comes to the realm of space weather. So it's always exciting to see a big uptick in sunspot count and the radio flux and so on, and that's what we are seeing. So take a moment to press that share button. If you're new to the channel, press subscribe or you won't see the world's most comprehensive daily space weather content in your feed. Of course, all YouTube creators are well aware that we have tons and tons of views that are not by subscribers. So it's kind of strange. It's like, I think people think that they're punishing a channel by not subscribing to it, which is just very bizarre because channels aren't paid for subscriptions anyway. Channels are paid for views, so there's that. But yeah, so we got major sunspots having risen in the southeastern limb of the closest star. And in the northeastern limb, we had an X-class solar flare. So that's what you want to see when it comes to space weather. We also have a very high likelihood of additional large solar flares and indeed earthly directed coronal mass ejections. So thanks for tuning in, everybody who has. Let's get down to some space weather stats. We've also got some significant snow forecasted. Looks like about 4 or 5 inches forecasted for here in Lehigh Valley, PA. And, I like snow, so I'm not complaining about that. So as far as the space weather stats go, the sunspot number is going to continue to rise here. It's currently already up to pushing 150 sunspots. We got about 148 sunspots right now, so that's a lot of sunspots. They have the radio fluxes at like 180 right now. We'll get to it here in a moment. But here is the sunspot number graph. I know people like to see visuals, so here you go. So there you go, pushing 150 sunspots here. Like we said a few weeks ago, sometimes you get down to very low number of sunspots, almost down to 0 here, so close to solar maximum, barely a year after solar maximum right now. So, but this is a totally normal thing, and thanks for leaving a comment, Dixie Floor 1409. Hi. So let's check the Huxt forecast next. I don't think we have any currently Earth-directed coronal mass ejections. Although there was a spectacular one last night that we will show you here in a moment. Show you some sweet coronagraphs. And let me just, I have to move a thing and do a thing with a thing. So let's show some images of the closest star here in the meantime. And I would note that we've got major dark absorption features here. Look at this radiant looking dark absorption feature around this sunspot group. So this is the kind of thing that you see associated with really massive coronal mass ejections. Look at all these filaments in here. Now, they are pretty bright. There's also a massive filament up here that's hundreds of thousands of kilometers, if not millions of kilometers in length. So really significant stuff going on here. And these sunspots down here, they do harbor the kind of magnetic fields that we would want to see if we're hoping for X-class solar flares. So this is exactly what you want to see. Although they're not particularly complex sunspots, they do have some significant magnetic shear to them, and that is what you want to see if you want to see solar flaring. If you're frightened of solar flaring, then now's the time to get into the bunker, because this sunspot up here has already produced an X-class solar flare. We'll show you the graph on that momentarily. So I guess we'll cut right to the coronagraph now, since I already talked about it. I mentioned the coronagraph, which is what shows us solar flares. I mean, it's not solar flares. It's what shows us coronal mass ejections. So the coronagraph, here we go. It's the GOES 19. So yeah, major CME happening early this morning on December 1st. Kicking off December right with major coronal mass ejections. So we have multiple events here. These do not appear to be earthly directed, in my opinion. Moving on to what NOAA has to say about it. NOAA does not have any significant space weather in the forecast. Chance for geomagnetic unrest in 2 days here, but at the moment, no new Earth-directed solar storms. Current solar wind conditions are a little bit of an elevated solar wind velocity here, solar wind speed about 500 kilometers per second. Solar wind density here about 7 protons per cubic centimeter, but somewhere between 3 and 7 looks like it's going to be a pretty valid number there. And as far as the field strength, it's not very strong. Total field is 4 nanotesla with a BZ of -2. No spike in the proton flux. Tamitha Skov thinks there may be a solar energetic particle event coming. I would tend to disagree on that because of the location of that flare being wrapped around the eastern limb. Now, if it was wrapped around the western limb, we would likely see a proton event. Here's that flare we were talking about. It is an X1.2, I think. Almost an X2 class flare there at 1.9. Keep in mind, folks, an M-class flare is 10 times stronger than a C-class flare, and a C-class flare is 10 times more powerful than a B-class flare, and an X-class flare is 10 times more powerful than an M-class flare. This is a magnitudinal scale here. And let's see what stereo A saw. Since we did have that massive CME, let's show you from a different angle here, just real briefly. Hopefully we will have the data on that. Looks like I'm not so sure. There we go. Data is present. So yeah, and as you can see, this looks like it's well on the left of stereo A. So somewhat behind the solar limb from Earth's perspective. Again, not likely earthly directed here. There may be some minor earthly directed components that are kind of mixed into the solar wind there, but no major impacts are likely from that massive CME associated with that X-class flare. Now, we don't say flares cause CMEs or that flares are CMEs. We try to not conflate those so people don't get confused about separate types of phenomena. Because remember, folks, a solar flare is photons and a coronal mass ejection is protons. So just imagine shining a light. A flare is like this. If your flashlight could shine X-rays, that's what a solar flare is. It's photons. But a CME is more like this. Protons, gas. So next we'll show the coronal hole line of sight plot here. This is showing us that there is a small series of south pole oriented coronal holes here rotating through. Let's bring up the last image there. We do have actually both polarities here of coronal holes. We've got south and north pole oriented, but it looks like Earth is in a south pole oriented magnetic sector. Just to verify that, and indeed there will be a sector change coming, and this could happen rapidly here because if one coronal hole opens or closes, then this sector boundary could move rapidly. So, but at the moment here, a little south pole magnetic sector showing up. There's the final frame. Earth should be in a north pole magnetic sector by tomorrow. This is stereo B, by the way. Over here, that is the location of stereo A, that one coronagraph that we showed you just a minute ago. Boulder magnetometer is pretty unexciting. And let's bring up the latest images here. We'll show El Teide, Spain's magnetogram, located on the island of Tenerife. And now these sunspots over here, these aren't particularly exciting, but these sunspots here, a little bit more interesting. Now, this one has already demonstrated that it can produce X-class solar flares, but these down here do have some significant magnetic shear as well. And like I said earlier, we have a huge amount of coronal plasma filaments on the western edge of this sunspot group, and that does have the propensity to cause some volatility. I'll just say that. There's the whole disk magnetogram from El Teide, Spain, part of the Gong 2 National Sunspot Observatory. Next, we'll show, let's see, what do we got? We'll show we'll show Lermonth, Australia. There are sunspots at 677 nanometers wavelength. And we're going to zoom in on these new spots because I want to see if they've been evolving. So first, this one that produced this large flare. Excuse me. So it looks pretty stable here. This sunspot group here that produced that flare, we don't see any major changes happening in that. But it is pretty early to tell there because it is somewhat obscured by the solar limb. As far as these groups go, they're looking pretty stable as well here. No major changes. So, but we'll be keeping an eye on those. And when I say eye on, the pun is intentional. All right. And thanks for tuning in, all 6 of you. Please press the share button so that your friends and foes know that they too have access to the world's most comprehensive daily space weather content. Now, here are solar filaments. Back to El Teide again. Let's just make sure that is the most recent. And indeed, the imagery there is only 5 minutes old. So major plasma filaments here. There are some that do not appear to be showing up. They're probably too low in the corona to appear at this H-alpha wavelength. So we're looking at hydrogen alpha. This is literally looking at hydrogen itself. And look at all the filaments. I mean, absolutely massive. This one up here is definitely name-worthy. And these 3 down here are all name-worthy. And guess what? They are certainly capable of producing Earth-directed solar storms. If they, especially this one, if this one lifts off right now, this one is very likely to produce a major Earth event. So eyes on this sunspot group. It is looking promising for producing some action. And of course, on this group up here, which has already produced an X-class solar flare. GOES electron flux here is in electron storm levels, so expect pretty bad GPS performance today. If you're relying on your GPS, don't expect it to work great. Make sure you have on your Wi-Fi location accuracy services. If you have access to those might help you out. If there are Wi-Fi hotspots around. Now we're going to look at the ionosphere real quick. This is going to show you those hotspots where your GPS is likely to not work well. So here's the raw data in the ionosphere. That's the vibrational frequency shown in megahertz. That's millions of vibrations per second. And this will show you the ionosphere heating up there at the daytime and cooling off at nighttime, especially around the equator as it does. I would note that the South Atlantic anomaly is now in the Pacific Ocean once again. And let's show the anomalygram. This is anomaly in megahertz from the 30-day median. If you're wondering where the South Atlantic anomaly is, it's right here. You can clearly see that right there, right on the equator, off the west coast of South America. So if you follow the South American coast to the equator and turn west a few hundred miles, and you'll be at the South Atlantic anomaly, directly under the South Atlantic anomaly, that is. It's clearly out here now. I mean, you can clearly see that. And the raw ionogram image will verify that as well. You can see it's moved way up here. And that's just how it is. These are facts. Like them or not, those are the facts. And thanks for leaving a comment, WRXSTI 1987. Pardon my voice. It is not optimal today. Still got some laryngitis here following the flu and a secondary infection. But no antibiotics. So we're updating my bodily firmware. Let's show the sun here in 94 angstroms because it's good at showing flares. And we have a high likelihood of flares. So there's that. We're going to also show you a brief weather forecast here since now we're getting into the realm of snow. So just bear with me a minute. I'm going to shift gears and talk about weather, Earth weather. So we're going to show the jet streams here while I mess around with a tab. So here are the jet streams of planet Earth. We're looking at null school here, and I like to use this to look at the jet streams because it gives me insight into what's happening with weather. We've got a massive kink in the jet stream here. This is probably going to cause a Pineapple Express situation. A bunch of moisture is going to move across Baja California, likely here, but the real story is this cold Arctic air. Look at this cold Arctic air blasting down into the entire west of the Mississippi half of the country. And you may see that surface winds are totally unrelated to the jet stream. So there are our surface winds, heavy winds on the East Coast, and a strong low here, southeast of Iceland. So right up here, a strong low up here. But yeah, that's what's going on in the U.S. Once again, there are the jet streams. That is the 250 hectopascal winds. Very rapid south to north jet stream here, pulling warm air to Nova Scotia and Newfoundland. But if you look right here, jet stream here blowing at 156 miles per hour. So quite a strong jet stream here. Expect returning from European flights to go right over the Atlantic because the jet stream's pretty clear there. You can get an efficient flight here, traveling east to west. Anyway, let me just bring up a forecast. Well, let's show some more data here. Let's just show temperature at the surface level. And there you can see that cold air creeping all the way down to Texas. So down here in northern Texas, below freezing there in northern Texas. Now I'm going to bring up a snow forecast here. We're going to show you the snow precipitation because there is some significant snow in the forecast. We're just going to show you the GFS model at this point. But 3-day forecasts are accurate, and that's why we like to show them on the channel. So there you go. There's your GFS 72-hour total accumulated snow precipitation forecast. Positive snow depth change in inches. And oh, this has just recently changed here. This looked differently just this morning. So the Mid-Atlantic, which is Maryland, Delaware, New Jersey, New York, and Pennsylvania, they've been downgraded here a little bit. But it still looks like 6 inches are possible. So significant snow here. Colorado is going to get the most, it looks like, per capita snow there, with some areas around 2 feet there in the higher mountains. So that's a GFS forecast for a positive snow depth change. And let's just show some more data here on windy. We'll close out with some satellite imagery and then go back to the sun briefly. And then take your comments if there are any more of them. Thanks to everybody who's left comments. Congratulations on realizing the channel exists. At this point, frankly, we are surprised. You know, many people thought that censorship was cured a couple of years ago. Censorship is actually worse than it's ever been, including on Twitter. So, morning penguins. Hey there, Bruce. It's probably a little warmer where you're located. than where I am. And shout out to Smash staff for letting me borrow her German Flecktarn military issue hat. The German Flecktarn camo pattern is a classic, still worn actively by the German military. So yeah, a little on the cool side, and bonjour to Destruction Maker Powder. Thanks for commenting there, All the Sun 7114 as well. And cheers. Here is the satellite data from windy.com. Windy.com's got a great mobile app. If you've never checked it out, perhaps you ought to. And there you can see the satellite imagery both on the dark part and the light part of the planet. Give that a minute to load up. It's pretty sweet animation there. It does show lightning as well. There's quite a bit of lightning there in the central Atlantic there, around places like Bermuda. And we can overlay this with the radar if you'd like to see where the precip is currently happening. There's a radar overlay that shows you the last hour. Let me shrink it down a little bit here. Make sure we show you the entire lower 48 at least. And all of Canada and Mexico there. So there's North America for you folks. That's what's going on here on planet Earth. All right, so we're going to cut back to the sun here and then cover any additional comments and then close this mother out. Again, stay tuned for additional space weather. If more stuff happens, more videos will come out on the channel. Let's briefly look at 171 angstroms here. The house favorite wavelength on the GOES 19. Exciting stuff. This depicts the past about 2.5 hours. And we'll zoom out to the full star view so you can see the time and date stamps. So, welcome to December. Congratulations on surviving another month. That's what's going on at the moment. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. I'll let this 304 angstroms imagery play here for a little while because, well, there's plenty going on. And you can see some coronal mass ejection activity happening over here on that eastern limb. So that's where it's at, the eastern limb. As more exciting times happen for space weather. So thanks again, viewers. See you soon here at the Smash News Network, least busted name in news. Please utilize English in the chat. Yeah, Bruce, have a sweet day yourself. Or I'll have a sweet day, you'll have a sweat day. I think that's the way it works. You have a sweat day, I'll have a sweet day.